Hi friends, welcome back to BitSize Machine Learning, and we're going to continue on our end-to-end ML in 15 steps. Today's episode is on the first step, which is set up the environment. So let's get started. To set up the environment, we first open VS Code, and then in VS Code, we're going to select the Python environment. And then after that, we're going to go through a few steps to actually set up our environment. So the first thing we need to do is Python version checking. So in order to do that, we're going to do an import of system module, and then we're just going to print out sys.version. And then when you do that, it's going to give us the Python's version 3.12. So it's recommended to use 3.8 or above to do well in this project. Okay, so that's the first step that we're going to do. The second step is installing packages. So if you haven't already, you can just use pip install, and we're going to just install some of the useful packages. The first one is NumPy, the second one is pandas, the third one is Matplotlib, and the next one is scikit-learn. So after that, we're going to just run this. So if you have already installed all of these packages, it will just say requirement already satisfied, so you don't have to worry about it. So the next step that we're going to do is importing packages. In order to use the functions, we have to import the packages those functions live. Okay, so in order to do that, let's first from the Matplotlib module, which comes with Python, so you don't have to install it. From Matplotlib, we're going to import path function. After that, we're going to import NumPy as NP. So this is just basically a alias. And we're going to import Matplotlib as NPL. And we're also going to import matplotlib.pyplot as PLT. And we're also going to import scikit-learn, which is the scikit-learn package. So after you put all of this, we're just going to run it, and it's successful. So that's the importing packages step. After this, we're ready to do our directory setup. So we do this step to organize our files better. To do this, let's first set up a base directory. Base directory is equal to using the path function's home function. And then this is just going to give me the folder structure for my home. And then in that, I'm going to use the projects folder. And underneath projects folder, I'm going to create BitSize ML folder. And that's the base directory. And then I'm going to create another variable called project name. And then project name is just going to be anything that you want. I'm going to do it end-to-end ML. And then after that, I'm just going to create the project directory itself. Project directory is going to be equal to the base directory. And then underneath the base directory, I'm going to put the project name. So that's going to create the project directory for me. Just run it. So that ran. And then the next thing that I want to do is to create subdirectories that live underneath this big project directory. To do that, I'm going to create the subdirectory names inside a Python dictionary. So for example, so the images are going to live inside the images folder. So the data will live inside the data folder. And notebooks will live underneath the notebooks folder, and then the models will live underneath the models folder. So that's the subdirectory that I want to create. So I've just created a subdirectory that stores the relative path of my files. In order to do an absolute path, which I'm going to use later, I'm going to create a dictionary. In order to do that, I'm going to use dictionary comprehension, name, and then project directory underneath is relative, and we're going to do resolve. And after that, we're going to loop through the dictionary we created. So for name relative path, we're going in this subdirectory .items. And then this is going to loop through the subdirectory, the name, and then the values. And then we're going to create the resolve function is going to create the absolute path for each one. So let's just print out what we've just created here. So as you can see, for the each files here, we have created its full path, absolute path. So after that's done, we're ready to create the file structure themselves. To do this, we're just going to do for p in this path. We're going to loop through its values, and then we're ready to do the p and kdir. And after that, the parents is equal to true, and we can do it if exists. It's okay as well. So it doesn't give us a warning. Okay, so after that, we're just going to run it. So now let's go check the file structures. So as you can see, underneath the projects, I've selected BitSize ML, and BitSize ML, there's end-to-end ML. This is the project. And then underneath, we have data, we have images, we have models, we have notebooks. So that's created quite nicely. Okay, let's go back. Now that we have a good structure for our project, we can go to our next step, which is step number 5, custom figure saving. It's not mandatory, but it makes figure saving quite easy for our next step. So I would recommend that you go through with that as well. To do this, we're going to create a function called saveFigure. SaveFigure has a few parameters. The first one is the name of the figure. The next one is the extension of this file. And the next one is called DPI. And the next one is the type layout or not. So let's just configure this. So the name is going to be string type, and then we don't have its default value. The extension is going to be a string type as well, but we're going to give it a PNG as default value. DPI is going to be an int value, and it's going to have a 300 as its default value, and then type is going to be a Boolean value, and then let's just say it's true. Okay, so these are the 4 parameters that we're going to use, and within the body of the function, we're going to create a variable called path, and then we're just going to use the path variable that we created earlier, and then one of which is images. And then images, we're just going to create another file within it using the fstring. Fstring, we're going to use the name parameter, that's the first parameter, and then dot, and the extension parameter. So that is the path of the file. And then after that, like we have the fourth parameter here, it's called tight. It's useful because we can check if it's tight layout or not. So if tight is true, then we're going to do plt is going equal to tight layout function, and it just makes a tight layout as well. The next step is actually saving the figure using the plt's save figure, and then the first parameter is actually the path that we just created, and the next parameter is going to be the format. Format is going to be just extension. In this case, the PNG is our extension, and then DPI is equal to DPI. So that's and then the last part, I'm going to just do a print statement, say saved, and I'm just going to give the path afterwards. So that is our custom figure saving function. So let's just run it. So it's stored. Now that we have already saved our function for custom figure saving, we can check if this is working correctly. So in order to do this, let's create a variable called x. From NumPy, we're going to use the linspace function, which is going to create from 0 to, say, 2 times np.pi and 200 values. So it's going to create from 0 to this value, and then we have a total of 200 values. And then y is equal to, let's say, np from the NumPy package, sine. Let's calculate the sine of all of these x values. And after that, we are ready to do plt figure function. This creates the figure canvas. And then after that, we're going to just plot x against y. And then after that, we're going to do a title. Title is just basically checking. After that, we're going to give us the x label. X label is equal to x. And then plt y label is equal to y, or just sign of x. And after that, we are ready to plt, or we can just actually save it first. Save figure, this is the function we just built, and we're just going to give the name of what this is. So checking env or environment checking. So after that, we're ready to do the plt show to show it. And then at the end, we're going to just do a close of the plt. Now we're ready to run this. Let's just quickly run it. So saved. So the figure is created here, and then this same figure is saved in this path that we've just designed. So these are all of the folders that we created before. Let's just quickly check if the image is actually there. So the env checking PNG is actually there. Okay. Now let's quickly summarize what we've just done. So first we checked the Python version, which is we first checked the Python version, then installed some of the packages. Then we imported up the packages that we are going to use in this project. Then we set up the directory structure for the project to organize it better. And after that, we created a custom figure saving function to save figures faster. And at the end, we did a quick sanity check if a figure is correctly saved into our project or not. So that's the first episode of our end-to-end ML project. So see you in the next one when we are actually fetching the data and taking a look at the data.